Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for better preparation of your exams. So today students, we will be solving JEE 2023, JEE 2023, 8th April, Shift 2 question paper. In this particular video, I'll be solving physics part of the question. Okay. So now starting our question series, the question number 31 of this series says that a hydraulic automobile lift is designed to lift vehicles of mass 5000 kg. The area of the cross section of the cylinder carrying the load is 250 centimeter square. The maximum pressure the small piston would have to bear it. So we have to find the maximum pressure. Students, this question is from the chapter of properties of solids and liquids. Okay, this question is directly from the Pascal's law. So we have to apply Pascal's law here. So what is Pascal law? According to Pascal law, whenever we apply pressure on a confined liquid, it is transmitted or it is distributed uniformly in all the directions. So according to this question, there is a hydraulic automobile lift. So let us explain it as, let us say this is our hydraulic lift, okay? And a hydraulic lift, and it is designed to lift vehicle of 5000 kg. Let us say this is piston, this is also piston, and it is having a mass of 5000 kg, okay? And the area of this cross section is given as 250 centimeter square, and area is given as 250 centimeter square, okay? So we have to find the maximum pressure on the smaller piston. We have to find the maximum pressure the piston can bear. So according to Pascal's law, delta P transmitted throughout the liquid is equals to force over area. Okay. Here in this case, the downward force F will be equals to mass into gravity. Okay. So delta P pressure will be equals to force mass into gravity over area. Mass is given as 5000, taking gravity as 10 over area 250 centimeter square means 250 into 10 to the power minus 4. Solving it, 25, 20 into 10 to the power 5. So it will be equals to 2 into 10 to the power 6 pascals. So the pressure is 2 into 10 to the power 6 pascal. So the correct answer is option D, 2 into 10 to the power 6 pascal. Okay. Now, moving towards our next question, question number 32. The question says that the angular momentum of a satellite is L. And orbital angular momentum is L when it is revolving in a circular orbit at a height h from the Earth's surface. Okay. If the distance of the satellite from the Earth center is increased by 8 times to its initial value, the new angular momentum will be. So this question is directly from the atomic and nuclear physics chapter. Okay. So now understanding this question, the orbital angular momentum of a satellite is L when it is revolving in a circular orbit. Let us say this is our planet M and a satellite is of mass M is revolving around it. Okay. Now its orbital angular momentum is L. We know that the orbital angular momentum L is equals to mvr. Okay. And V is the velocity here, or orbital velocity, and orbital velocity is equals to under root gm upon r. So this angular momentum L will become m into under root of gm over r into r. So L will be equals to m under root gm into r. So here we can say that L is directly proportional to under root of r. Okay. Now the question says that if the distance of the satellite from the earth center is increased by 8 times, it is not saying 8 times. It is saying by 8 times. By 8 times means if at first the distance is r, so now the new distance will be r plus 8r, 9r. Okay. If the question says 2, so we will use only 8r. Since it is saying by, so we will add r plus 8r equals to 9r. So the new orbital angular momentum will become under root of 9r, that is L is directly proportional to 3r. So our correct answer is 3L. Okay. Under root of 9r means 3 root r. So let us say is L dash. So L is equals to under root of r, and L dash is equals to 3 under root of r, root r cancel. So L dash is equals to 3L. Okay. So the correct answer is B. Option B is, that is L dash will be equals to 3L. Got it? Yeah. So now moving towards next question, question number 33. The waves emitted when a metal target is bombarded with high energy electrons. So students always remember it is from the electromagnetic waves chapter. Always remember that whenever a wave is emitted to, when a metal target is bombarded with high energy electron, the theory says that whenever a metal target is bombarded with a high energy electron, it always produces X-rays. Always remember that whenever a metal target is hit with high energy electron, it always produces X-rays. So the correct answer is option B. Okay. Now, next question, question number 34. Okay. Now, this question, we have to find the units of it. So, this question is directly from our first chapter of units and measurement. Okay. Now, we have to find it. The first one is torque. Okay. Torque. Torque is equals to force into length, F into L. So dimensions of torque will be force into length. Force, dimension of force, M L T minus 2 into L. It will be equals to M L square T minus 2. M L square T minus 2. So the correct answer of A is second. Then stress. Stress is equals to force upon area. For dimension ML T minus 2 over area L square. So it will be equals to M L minus 1 T minus 2. So stress equals to M L minus 1 T minus 2. M L minus 1 T minus 2. Okay. Then pressure gradient. Students, whenever this gradient word comes, so it means that we have to find its derivative with that quantity. So pressure gradient means delta P over delta L equals to F over A square into L. So it will be equals to MLT minus 2 over L cube. So it will be equals to MT minus 2 over L square means ML minus 2 T minus 2. The pressure gradient will be equals to ml minus 2 t minus 2. Now, coefficient of viscosity. The coefficient of viscosity for it, the force is equals to 6 pi eta r into v. 6 pi is constant. Okay. So, eta coefficient of viscosity will be equals to F over r into v. F m L t minus 2 over r into v. R is L. V is velocity L t minus 1. So, eta will become m L minus 1 t minus 1. So the dimension for coefficient of viscosity is m L minus 1 t minus 1. So the correct option is option D. Okay. Now our next question, question number 35. This question says that statement 1, area under velocity time graph gives the distance traveled by the body in a given time. And statement second is area under oscillation time graph is equal to the change in velocity in the given time. This statement is wrong, students. Why? Because the area under velocity and time graph always gives us displacement, not the distance. So the statement 1 is incorrect. Okay. And the second statement is area under oscillation time graph is equal to change in the velocity. This is true. Why? The area under oscillation in time graphs, since let us say this is our graph, this is velocity v1, this is velocity v2. So area under this graph, area under this curve will be equals to v2 minus v1, means the change in the velocity. So this statement is very true, which says that area under oscillation time graph is equals to change in the velocity in the given time. So our correct answer is statement 1 is incorrect, but statement 2 is correct. Okay. Now moving towards our next question, question number 36, which says that the power radiated from a linear antenna of length L is proportional to. Student, this is the direct formula. This question is from the communication chapter, and this is a direct formula. Power is always equals to length over wavelength whole square. Means power P is equals to L over lambda whole square. This is a direct question. So the correct answer is option D, L over lambda square. Now moving towards our next question, question number 37, which says that the electric potential at a point P due to a point charge is itna 50 volt. The point charge is given as 5 into 10 to the power minus 9 coulomb, and the electric potential is given 50 volt. The distance of P from the point charge, we have to find the distance, means we have to find R. Okay. This is from the electrostats chapter. So we know that simple formula for potential V is equals to, this is the very basic formula. V is equals to 1 over 4 pi epsilon naught Q over R. So we have to find the value of R, distance R. So R is equals to 1 over 4 pi epsilon naught Q over V. Okay. The value of 1 over 4 pi epsilon naught is 9 into 10 to the power 9. So R will be equals to 9 into 10 to the power 9 into Q. Charge is given 5 into 10 to the power minus 9. And potential is given as V 50 volt over 50 volt. Now solving it, 5, 10, it will be equals to, R will be equals to 9 over 10. So it will be 0.9. Okay. Or 0.9. Okay, 0.9. Sorry, into 100, it will be equals to 9 into 5 over 50, na? Wait a minute, R equals to 9 into 5 over 50. 9 over 10, 0.9. So the correct option is option C, 0.9. Got it? Now, next question, question number 38. This question says that the acceleration due to gravity at a height h above the earth if h is very less than r. Okay, we have to find the acceleration due to gravity at height h above the earth. Okay, we know the very basic formula of gravity at the surface of the earth is g equals to gm over r square. This is the very basic formula for finding the gravity on the surface of the earth. Now, if we have to measure the gravity at a height h, so the formula becomes g dash equals to gm over r plus h whole square. Okay. Now, if it is saying the h is very less than r. Okay. Now, dividing g by g dash is equals to gm over r square over gm r plus h whole square. This gm cancels out this. So g over g dash becomes r plus h over r square, or we can write g dash over g as r square over r plus h square. Okay. Now taking r square common from the denominator. So it will become 1 plus h over r whole square. R square cancels out each other. So g dash over g becomes 1 over 1 plus h over r whole square. Now solving it, it becomes 1 plus h over r raised to the power minus 2. Using binomial expansion, g dash over g will become 1 minus 2h over r. Okay. So g dash is equals to g into 1 minus 2h over r. So our correct option is option D, g dash equals to g 1 minus 2h over r. Okay. Now, next question. The next question says that an EMF of 0.08 volt is induced in a metal rod of length 10 centimeter. Length is given as 10 centimeter, held normal to a uniform magnetic field of 0.4 Tesla. When moves with a velocity of, we have to find basically the velocity. So this question is from the electrostats chapter. Student, there is a very simple formula. The most basic formula between EMF and magnetic field is EMF is equals to BLV. Okay, so here EMF is given as 0.08 volt, length is given as 10 centimeter, and magnetic field is given. Just we have to put in the values of these into this formula and we will find the value of V. So V will become EMF over BL, EMF 0.08 over magnetic field B 0.4 into 10 centimeter. 10 centimeter means 10 over 100. So it will become V will be equals to V will become 0.8 over 0.4. It will become 2. So V is equals to 2 meter per second. So the correct answer is option A, V equals to 2 meter per second. Okay. Now moving towards our next question, question number 40, which says that work done a Carnot engine operating between temperatures 127 degrees Celsius and 27 degrees Celsius is 2 kilojoule. The amount of heat transferred to the engine by the reservoir is. This question is from the chapter of thermodynamics. Okay, it is saying about the Carnot engine. So basically what is Carnot engine? In Carnot engine, there is a source there is a heat engine between it, heat engine, and then is a sink. Okay, so the amount of heat that is transferred from source to heat engine is Q1, and the amount of heat that is transferred from heat engine to sink is Q2. So a term called eta, eta is the efficiency, it is equals to 1 minus T2 over T1. Okay, so this temperature is T1, this temperature is T2. Here T1 is, always remember, the temperature of source is always greater than the temperature of sink. Here T1 is the temperature of the source, so T1 is equals to how much? 127 degrees Celsius means 127 plus 273 equals to 400 Kelvin, and T2 is equals to 27 plus 273 means 300 Kelvin. Okay. So eta will become, eta equals to 1 minus T2 over T1. It will become 400 minus 300 over 400. It will be 100 over 400 means 1 by 4. Okay. Another formula for finding the efficiency is eta is equals to work done over Q1. Q1 is the heat supplied from source to heat engine. So here from the question, work done is given as 2 kilojoule. So 2 over Q1 and eta is 1 by 4. So we get Q1 is equals to 4 into 2, 8 kilojoule. This is our final answer. So Q1 is, option D is correct, 8 kilojoule. Okay. Now moving towards our next question, question number 41. This question says that the width of fringe is 2 millimeter on the screen in a double slit experiment for the light of wavelength of 400 nanometer. The width of the fringe for the light of wavelength 600 nanometer will be. So student, this question is directly from the chapter of wave optics. It is of Young's double slit experiment. So what is Young's double slit experiment? In Young's there is a source. This is a coherent source. Okay. The light coming from it is coherent light. It is passing through a slit and wavefronts are coming from these slits and they are overlapping, and central fringes and alternating different bright and dark fringes are forming on the screen. So the distance between these fringes is D, and the distance between the slit and the screen is capital D. So for Young's double slit experiment, beta is equals to lambda D over D. Lambda is the wavelength of the incident light. So it is saying that the width of the fringe is 2 millimeter. Fringe width is 2 millimeter on the screen in a double slit experiment for the light of it. Wavelength is given 400 nanometer. So we have to find when the width of the fringe is 2 millimeter, at that time is wavelength is 400 nanometer. So when the wavelength is 600 nanometer, at that time we have to find fringe width. So the formula is beta equals to lambda D over D. It means beta is directly proportional to lambda, means fringe width is directly proportional to lambda. Therefore, beta 1 equals to lambda 1 and beta 2 equals to lambda 2. Therefore, beta 1 over beta 2 is equals to lambda 1 over lambda 2. So it will be equals to lambda 1 is 400 nanometer and lambda 2 is 600 nanometer, and at that time fringe width is 2 millimeter. So 2 over beta 2 equals to 400 nanometer over 600 nanometer. So 3. So beta 2 will be 3 millimeter. Got it? So the correct answer is 3 millimeter, option B. Now our next question, question number 42. It says that the temperature at which the kinetic energy of oxygen molecules becomes double than its value at 27 degrees Celsius is. So we have to find the temperature. Basically, we have to find the temperature. So student, this question is from the kinetic theory of gas chapter. Kinetic theory of gases chapter. Oxygen molecule. Oxygen is a diatomic molecule, and we know that the kinetic energy equals to N by 2 kBT, where kb is the Boltzmann constant and its value is 1.38 into 10 to the power minus 23 joule per Kelvin. Okay. So kinetic energy equals to N by 2 kBT. Since it's a diatomic molecule, so N value is 5. For it is for dia. For monoatomic, N is equals to 3, and for triatomic, N is equals to 6. Okay, since it's a diatomic molecule, the kinetic energy will be equals to 5 by 2 kBT. So kinetic energy is directly proportional to temperature. Okay, so the temperature at which the kinetic energy of oxygen molecule becomes double to that of its at 27 degrees Celsius means K1 equals to T1 and K2 equals to T2. And we have to find when the kinetic energy becomes double means K2 is equals to 2K1. So T1, we are given T1 with 27 degrees Celsius. 27 means 300 Kelvin. Okay. So K1 over K2 equals to T1 over T2. And K1 over K2 is 2K1 equals to T1 is 300 Kelvin over T2. K1 cancels out each other. Thus T2 equals to 600 Kelvin. 600 Kelvin means 600 minus 273. It will become 327 degrees Celsius. So T2 is 327 degrees Celsius. So the correct answer is option C. 327 degrees Celsius. Now, our next question, question number 43. This says that given below are two statements, one is labeled as assertion A and the other is labeled as reason R. Assertion A is electromagnets are made up of soft iron. This is very true statement, students. Electromagnets are always made up of soft iron, and the reason behind is given as soft iron has high permeability and low retentivity. This is the very true reason for this statement. So the correct option is option B. Both A and R are correct, and R is the correct explanation of A. Now moving towards our next question, question number 44. It says that the trajectory of projectile projected from the ground is given by y equals to x minus x square over 20, where x and y are measured in meter. The maximum height attained by the projectile will be. This question is directly from the chapter of kinematics. So students, always remember, whenever there is we are given equation of a graph, whenever we are given equation of a graph, then its highest value will be always dy by dx is equals to 0. Okay, the question itself says that we have to differentiate this equation with the respect of x. So we are given y equals to x minus x square by 20. So dy by dx equals to 1 minus 2x over 20. It will be equals to 1 minus x over 10. Putting dy by dx equals to 0, we get 1 equals to x over 10 means x is equals to 10. Now putting this value of x into this equation, y is equals to x minus x square over 20. So it will be equals to 10 minus 10 square over 20. It will be 10 minus 100 over 20. 20 minus 10 over 2, it will be 5. So the correct answer of y is 5 meter. That is option D. Okay. Now, next question, question number 45. This question says that a bullet of mass 0.1 kg moving horizontally with a speed 400 meter per second hits a wooden block of mass 3.9 kg kept on a horizontal surface. The bullet gets embedded into the block and moves 20 meter before coming to rest. The coefficient of friction, we have to find the coefficient of friction between the block and the surface it. Students, understand this question very carefully. This question says that there is a bullet of mass, there is a bullet whose mass is, a bullet is coming, its mass is 0.1 kg and it is coming with a speed of 400 meter per second. And it hits a block. There is a block. This bullet hits this block and the mass of this block is 3.9 kg kept on the horizontal surface, and these bullets get embedded into the block. And now this block moves with at a distance 20 meter and then it came at rest. Okay, means there is a bullet whose mass is 0.1 kg. This bullet is moving with a speed of 400 meter per second and there is a block of 3.9 kg and this bullet gets embedded in this, and after being embedded in this moves at a distance of 20 meter, then it came to rest. So we have to find the coefficient of friction from it for it. So applying the conservation of momentum. But conservation of momentum says the momentum before collision must be equal to momentum after collision, means m1 v1 must be equals to m2 v2. So m1, mass of the bullet is 0.1. It is moving with velocity 400 and after that its mass become how much? 3.9 plus 0.1 kg. It means 4 into V2. So V2 is equals to 10 meter per second. Means when this bullet gets embedded in this block now moving with, after this impact, this block is moving with a speed of 10 meter per second. Also, we know that kinetic energy it equals to work done due to friction. Okay. So here in this case, we apply this formula, half mv square equals to mu, coefficient of this friction, into mg into x. Cancels out each other. So mu will be equals to v square over 2gx. Okay. So v square, velocity will 10 square over 2 into g. G is given 10 meter per second square, 10 into x. X is how much? 20 meter into 20. So our answer is 10 over 2 into 20, that is 1 by 4. Mu is equals to 1 by 4. It means 0.25. So the coefficient of friction is 0.25. Option C is correct. Okay. Hey, Jams, now solving our next question, that is question number 46. This question says that for a given transistor amplifier circuit in CE configuration, VCC equals to 1 volt, RC equals to 1 kilo ohm, RB equals to 100 kilo ohm, and beta equals to 100. The value of base current IB. So this question is directly from the chapter of electronics devices. And this is basically from the part of transistor and PN transistor. Okay, here this is RC. RC is a resistor across the collector C. This is collector, this is base, and this is emitter. RB is the resistor across the resistor of base, and we have to find the base current IB. Okay, so there is a very simple formula for this, that is VCE equals to VCC minus IC into RC. For the saturation distance to 0, so VCC equals to IC into RC. So from here, the collector current IC will be equals to VCC over RC. Okay. So it will be equals to VCC. VCC is how much? 1 volt over RC. RC is how much? 1 kilo ohm. 1 into 10 to the power 3. So IC will be equals to 10 to the power minus 3 ampere. Okay. Now, another famous relation is that IC equals to beta into IB, where IC is the collector current, beta is the base current. So in the question we have asked base current. So base current IB equals to IC over beta. And IC is how much? IC is 10 to the power minus 3 ampere and beta is 100. So IC equals to 10 to the power minus 3 over 100. So it will be equals to 10 to the power minus 5. So it means 10 to the power minus 5 ampere. Now multiplying numerator and denominator with 10 to the power minus 1. So we get IB equals to 10 microampere. So the correct answer is 10 microampere. That is option B. Got it? Yeah, now moving towards our next question, question number 47. It says that a particle P revolving around the center O with radius of circular path r, angular velocity omega, as shown in figure, the projection of OP on the x-axis at time t is. So this is directly from the chapter kinematics. So we are given a circle whose center is O, and at time t equals to 0, it is making an angle of 30 degree with the center. So we have to, this is y. So at time t equals to t, okay. Let us say at time t equals to t, we have to find its projection on this axis. So its projection is this. Let us say this is x. So we have to find this projection x. So this x will be equals to, now resolving this angle, let us say this angle into two components x and y. So this will be x cos theta and this will be sine theta. So x will be equals to r, since this is r, this is r cos theta, this is r sine theta. So x will be equals to r cos theta. Theta means this whole angle. So this whole angle is 30 degree plus this is what? Omega t. So 30 plus omega t. So cos 30. So x will be equals to r cos this 30 plus omega t. It means omega t plus pi by 6. So the correct answer is option A. Xt equals to r cos omega t plus pi by 6. Okay. Now moving towards our next question, question number 48. This question says that a radioactive material is reduced to 1/8 of its original amount. Let us say at first the original amount is N naught. So it is reduced to N naught by A. The final value is now N naught by A. In how much time? T equals to 3 days. If 8 into 10 to the power minus 3 kg of the material is left after 5 days, the initial amount of the material is. So this question is basically from the chapter radioactivity. So students, this question is very important as this question has been asked in the previous years also. So solving this question using the general formula for the radioactive material, that is N equals to N naught e to the power minus of lambda t. Okay. This N over N naught, this N naught is the original value, this N is the final value, and this N over N naught is the amount that is left behind, means undecayed amount. Okay, left amount or amount that is undecayed. Okay, now it is saying that a radioactive material is reduced to 1/8 of its original amount. Let us say the amount at the very beginning is N naught. Now the left behind is N naught by 8. So in place of N, we write N naught by 8 equals to N naught e to the power minus lambda t. N naught cancels out each other. So it will be equals to 1 over 8 equals to e to the power minus lambda t. Now taking log on both sides, so we get log of 1 minus log of this 8 equals to log of e to the power minus lambda t. It means minus of lambda t, because log and e base cancels out each other. Log of 1 is 0, so we get minus log 8 equals to minus of lambda t. This minus minus cancels out each other, so we get lambda equals to log of 8 by t, and we are given t equals to 3 days, so upon 3, so lambda equals to log 8 by 3. This is our equation number 1. Okay, we have solved till this. Now the second statement is, if 8 into 10 to the power minus 3 kg of the material is left after 5 days. Left means we are given n over n naught. Okay, if this amount is, so we are given with n over n naught equals to 8 into 10 to the power minus 3 kg means 8 gram. Okay, now the initial amount of the material means we have to find the value of n naught. Since we know that n equals to n naught e to the power minus lambda t, this is the initial amount, this is the final amount, and we are given n over n naught equals to how much? 8 into 10 to the power minus 3 kg. So we write 8 gram equals to n naught e to the power minus lambda t. 8 equals to n naught. N naught is how much? 8 equals to n naught e to the power minus lambda. So we write n naught e to the power minus lambda. Lambda is L log of 8 by 3 into t. T is how much? 5 days. Let us say t only. Okay, so 8 equals to n naught e to the power minus lambda 8. 2 to the power 3, we can write it as 3 ln 2 by 3 into t. Got it? So 3 cancels out each other. So 8 will be equals to n naught e to the power minus of ln 2 into t. T is 5. So we can write it as 8 equals to, sorry, into 5, not t. So we can write it as n naught e to the power minus of 2 ln, sorry, minus of 5 ln 2. Okay, so 8 will be equals to n naught e to the power minus of ln 2 raised to the power 5, because whenever whatever it's in multiplication of log, it simply goes to the power of 2. So 8 will be equals to n naught e to the power minus ln 2 to the power 5. Now taking log on both sides, we can write uh, now this n naught will become n naught equals to, now this cancels out each other, we get n naught equals to 8 upon, no, sorry, we can write it as 8 equals to n naught into 2 raised to the power 5. So n naught becomes 8 into, since it is minus of ln 2, we can write it as 1 over 2 raised to the power 5. So it will become 8 into 2 raised to the power 5. Okay. So n naught is equals to 256 gram. Got it? I'll repeat it once again. At the very beginning of the question, we are given a radioactive material. It is reduced to 1/8 of its original amount in 3 days. So n equals to n naught e to the power minus lambda t. Since it is 1 over 8 of its original amount means n naught by 8. So here we write n naught by 8 equals to n naught e to the power minus lambda t. 1 over 8 equals to e to the power minus lambda t, since n naught cancels out each other. Now taking log on both sides, log of 1 minus log of 8 equals to minus of lambda t. This ln 1 equals to 0. So lambda becomes log of 8 by 3. Got it? Now the second statement says that if 8 into 10 to the power minus 3 kg of the material is left, so the left one is 8 into 10 to the power minus 3 kg, it means 8 gram. Okay. After 5 days, the initial amount of the material. So we have to find this value of n. So the left behind is 8 into 10 to the power minus 3 kg. So we write 8 equals to n naught e to the power minus lambda t. So solving this, since we get the value of lambda equals to log of 8 by 3, putting this value here and putting the value of t at as 5, solving this equation, we get 8 equals to n naught 1 over 2 raised to the power 5, 2 raised to the power 5. Since here is minus sign, na, so that's why we are writing 1 over 2 raised to the power 5. So n naught becomes 8 into 2 raised to the power 5. So therefore n naught is 256 gram. So our correct answer is this, option D, 256 gram. Okay. Now moving towards the next question, question number 49. This question says that the equivalent resistance between A and B as shown in figure. We have to find the equivalent resistance between A and B. Since the potential difference between all the resistor is same, the potential difference between this and this is same. So when the potential difference is same, we always say that they all are in parallel. Okay, got it? Now solving this, since these are all in parallel, so 1 over r equals to 1 over 20 plus 1 over 20 plus 1 over 10. Okay, now so 1 over r will equals to 20, 20, 10, 20, 1 plus 1 plus 2, 1 over r equals to 4 over 20. So R will be equals to 20 over 4. It means 5 kilo ohm. So our correct answer is option C, 5 kilo ohm. Okay. Now the next question is the photoelectric effect. So first of all, we should know what is photoelectric effect. The photoelectric effect is what basically whenever whenever photons they are incident on a metal surface. Suppose let us say this is metal surface. Whenever photons they are incident on a metal surface, the electrons from this metal surface are ejected out, and these electron induces a current called photoelectric current or photocurrent. Got it? Whenever electrons of sufficient intensity falls on the surface of a metal, the electrons get ejected out from the surface of the metal and they constitute a current called the photocurrent. Okay. Now, this statement A says that the photocurrent is proportional to the intensity of the incident radiation. This is very true. What? The photocurrent, the current that is produced due to the ejection of these electrons, it is directly proportional to the intensity of incident photon, gamma. This is very true. Intensity means number of the photons. Okay? So it means more number of photons means more intensity, and more intensity means more ejection of the electrons means more photocurrent. Got it? The second B is maximum kinetic energy with which photoelectrons are emitted depends on the intensity of the incident light. This is false because we know that in photoelectric effect the kinetic energy, maximum kinetic energy equals to initial kinetic energy minus work function. This initial kinetic energy equals to H into F, frequency minus work function. This H is the Planck's constant and F is the frequency. So the photocurrent depends on the frequency, not on the intensity. So this statement is wrong. The third is the maximum kinetic energy with which photoelectrons are emitted depends on the frequency of the incident light. Yeah, it depends on the frequency of the incident light. So this statement is true. D statement is what? The emission of photoelectrons required a minimum threshold intensity of incident radiation. This statement is wrong because whenever the photons of a sufficient intensity falls on the surface of the metal, so the electrons gets ejected out from the surface of the metal only when the frequency of the incident photon is greater than a saturation frequency. Okay, this F, it depends on the saturation frequency, not on the saturation frequency or threshold frequency. It depends on the threshold frequency, not on the threshold intensity. So this statement is wrong. Statement E is the maximum kinetic energy of photoelectrons is independent of the frequency. This statement is wrong. Why? It depends on the frequency, not independent of the frequency. So only A and C are correct. So the correct answer is option B. A and C are correct. Okay. Now moving towards the next question. Question number 51. This question says that a 600 picofarad capacitor is charged by 200 volt supply. Okay, let us say this is a capacitor. It is charged by a battery which is given a potential of 200 volt. Okay, it is then disconnected from the supply and it is connected to another uncharged 600 picofarad capacitor. Okay, at first it is connected to a battery giving a potential difference of 200 volt. Now it is disconnected and this capacitor, let us say C1, is now connected to another capacitor C2 having capacitance 600 picofarad and this also having a capacitance of 600 picofarad. Okay, फिर the electrostatic energy lost in the process is, so we have to find the energy loss. So this question is directly from the electrostats or so electrostats chapter. So we have to find the energy loss. So students, we have a general formula, very basic formula for the heat loss or the electrostatic loss. The heat loss formula for the capacitance, we all know, we have studied in the theory part also. Heat loss is equals to 1 by 2 C1 into C2 over C1 plus C2 into V1 minus V2 whole square. Okay, so it will become 1 by 2 since both have same capacitance 600 picofarad 600 pico. Let us say both have capacitance C. So this will become C into C over C plus C 2C into V1 minus V2. V1 minus V2 means V1 is the potential when they are not connected, means 200 volt, and 200 at that time V2 is 0 because since we have only one at that time when the potential difference is 200 volt across the capacitor C1, we don't have the another capacitor na. So for capacitor C2 the V2 will be 0. So solving this we get CC cancels out each other. It will be equals to 1 by 4 C into 200. So it will become 1 by 4 C. C means 600 picofarad. Picofarad means 10 to the power minus 12 into 200. Okay. Now solving this, we get 2223 300 into 10 to the power minus 10. So we get C1 plus C2. C1 plus C2 means 2C, na? Yes, correct. Okay, it's whole square, sorry. It's whole square. So we get 200 into 200 also into 200. So we get 6 into 10 to the power minus 10 plus 4. So we get 6 into 10 to the power minus 6. It means 6 microfarad. So our answer is heat loss will be equals to 6 microfarad. So the answer is 6 microfarad. Okay. Now moving towards on next question. Question number 52. This question says that a series combination of resistor of resistance 100 ohm, inductor of inductance 1 Henry and capacitor of capacitance 6.25 microfarad is connected to an AC source. Okay. It is connected to an AC source. The quality factor of the what? Circuit will be, we have to find the quality factor of the circuit. So at first, the formula for quality factor, it is very basic formula. The quality factor is equals to resonance frequency over the bandwidth. Okay, resonance frequency over the bandwidth. So resonance frequency equals to omega r over bandwidth. Bandwidth is del omega. So the omega r equals to 1 over under root of LC. It is from LCR series circuit, you can say, or from the capacitance chapter. Okay. LCR chapter or capacitance chapter, sorry. 1 over under root of LC and delta omega equals to R by L. Omega r is the resonance frequency. Resonance frequency is equals to how much? 1 over under root of LC, and del omega is the bandwidth, and del omega equals to R by L. So solving this, we get quality factor Q equals to 1 over R under root of LC. Now putting all the numerical values, R is given how much? 100 ohm. L is given 1 Henry, and capacitor is given 6.25 to 5 microfarad. So it will be equals to 1 over 100 into under root of 1 over 6.25 into 10 to the power minus 6 microfarad, na 10 to the power minus. So solving this, we get 1 over 100 into 1 over 2.5, 625, 6.25 na. So under root of 6.25 is 2.5 into 1 over 10 to the power minus 3. So solving it, we get 4. The quality factor is equals to 4. Okay, now moving towards our next question, question number 53. This question says that the number density of free electrons in a copper is nearly 8 into 10 to the power 28 per meter cube. A copper wire has its area of cross section equals to 2 into 10 to the power minus 6 meter square, and it is carrying a current of 3.2 ampere. The drift speed of the electron is, we have to find the drift speed. So normally, the current for these free electrons I is equals to NeAVD. Okay. So I is given how much? We have to find the drift speed. So we have to find this VD. So VD is equals to I over NeA. Current is given how much? 3.2 ampere. So 3.2 over N. N is how much? 8 into 10 to the power 28, and E is 1.6 into 10 to the power minus 19, and area is 2 into 10 to the power minus 6. Now solving it, we get 8.4 over 1.6 into 2 into 10 to the power minus 28 plus 19 plus 6. So solving it, we get 0.2 1 by 8 into 10 to the power minus 28 plus 25. So it will become 125 into 10 to the power minus 6 meter per second. So the drift speed VD equals to 125 into 10 to the power minus 6 meter per second. Okay. Now next question is question number 54. This question says that a hollow spherical ball of uniform density rolls up a curved surface with an initial velocity of 3 meter per second. We have to find the maximum height with respect to the initial position covered by it. It will be. So this question is from the chapter of kinematics. We are given that there is a ball. It is moving with a speed of 3 meter per second, and it is moving like this. Okay. We have to find the height up to which with respect to the initial position covered by it. So for this type of question, the when it reaches to a height h, it will lost all of its kinetic energy, and at this point the kinetic energy will change into potential energy. Basically there will be potential energy. So the loss in kinetic energy will be equals to gain in potential energy. Okay. The loss in kinetic energy equals to half mv square k plus 1 equals to mgh. We have to find this height now. For since it is a hollow spherical ball, so for hollow spherical ball, the value of k equals to 2 by 3. So solving it, m cancels out each other. It will be equals to 1 by 2. Velocity is given 3 meter per second. So 3 square, 2 by 3 plus 1 equals to g. Taking g 10 meter per second square. So 10 into h. Solving it, we get 1 by 2. 3 into 3, 339 into 3, 5 by 3 equals to 10 into h. So we get this 3. 15 by 2 equals to 10h. 5 2s are 10, 5 3s are 15. So h will be equals to 3 by 2 into 2. So h becomes h equals to 3 by 4 equals to 0.75 meter, or we can say 75 centimeter. Okay. So our answer is 75 centimeter. Now next question. So students, now solving our next question, question number 55. This question says that a steel rod of length 1 meter and cross-sectional area 10 to the power 4 meter square is heated from 0 degrees Celsius to 200 degrees Celsius without being allowed to extend or bend. The compressive tension produced in the rod is, we have to find basically what tension. So this question is directly from the chapter of properties of solids and liquids. Okay, according to this question, the rod is not allowed to extend or bend. Suppose this is rod, it is not allowed to extend and or bend. Initially, the change in length delta L will be equals to L alpha delta T. So if it is not allowed to extend or bend, so delta L over L will be equals to alpha into delta T. Okay. Now the thermal stress is equals to Young's modulus into this strain. This is basically what strain na. So thermal stress, force upon area, is equals to Young's modulus into this strain. So F over A equals to Young's modulus into delta L over L. So F is what here? F is tension here. So this tension equals to Young's modulus into alpha delta T into this A. So Young's modulus is given as how much? Coefficient of linearity. Okay. So it will be equals to 2 into 10 to the power 11 into area. Area is how much? 10 to the power minus 4 meter square. So it will be equals to 10 to the power minus 4 into delta T into alpha into delta T. Na? So alpha is what? 10 to the power minus 5 into what? Delta T. Delta T is 0 degrees Celsius to 200 degrees Celsius, means delta T is 200 degrees Celsius. Now solving this, 2 to 4 into 10 to the power minus 4 minus 5 plus 11 plus 2. So it will be equals to 4 into 10 to the power minus 9 plus 13. It will be equals to 4 into 10 to the power 4. So comparing it with this given, so we get x equals to 4. Got it? So our answer is x equals to 4. Now moving onwards, our next question. Question number 56. This question says that the ratio of magnetic field at the center of a current carrying coil of radius r to the magnetic field at a distance r from the center of the coil on its axis is under root of x ratio 1. We have to find the value of x. Okay. Suppose this is a current carrying coil. Its radius is r. Okay. And the ratio of the magnetic field at the center of a current carrying coil of radius r to the magnetic field at a distance r from the center. Okay, we have to find the ratio of magnetic field at the center and the ratio of the magnetic field at this point P. Basically, magnetic field passing through the axis on the axis is equals to, the formula for this is mu naught I into r square over 2 r square plus x square raised to the power 3 by 2. Got it? So, B axis magnetic field when x is equals to r at a distance of, let us say it's, we write it as r. When x is r, so it will be equals to mu naught I into r square over 2 r square plus r square raised to the power 3 by 2 over B axis on the axis when at the center, means x is equals to 0. So it will be equals to how much? Mu naught I r square over 2 r square plus x square, x is 0, 0 square raised to the power 3 by 2. Now solving it, mu naught I cancels out each other, r square cancels out each other, 2 cancels out each other. So we get, solving it, we get 1 over r square plus r square raised to the power 3 by 2 over 1 over r square raised to the power 3 by 2. So we are left with r cube over 2 raised to the power 3 by 2 into r cube. R cube cancels out each other. So we get 1 over under root of 8. So B at x equals to 0 over B at x equals to r, means at the center and at a distance r equals to under root of 8 by 1. So the correct answer is under root 8. Okay. Now next question is question number 57. This question says that the ratio of wavelength of spectral lines H alpha and H beta in the Balmer series is x by 20. We have to find the value of this x. Okay. Now we know that the series Lyman, Balmer, Paschen, bracket, P-fund, x equals to 1, 2, 3, 4, 5. ठीक है? This is Lyman, this is Balmer, this is Paschen, bracket, and P fund. Okay. When the transition is from n equals to 3 to n equals to 2, we get H alpha line. When the transition is from n equals to 4 to n equals to 2, we get H beta line. So there is a famous relation, mu equals to 1 over lambda equals to r Rydberg's constant into 1 over n1 square minus 1 over n2 square. Okay. Now solving for H alpha and H beta, we have to find the ratio of H alpha and H beta, na? So for solving this, for H alpha, let us say for H alpha, it will become R 1 over n1 square. n1 is always what? 2. 2 square 4 minus 1 over 3 to 2. H alpha is coming from 3 to 2. So 1 over 2 square minus 1 over 3 square 9. And for H beta, it will be r 1 over 4 to 2 na. 2 square means 4 minus 4 square means 16. So 1 over lambda h alpha equals to r 1 over 4 minus 1 over 9 upon 1 over lambda h beta equals to r 1 over 4 minus 1 over 16. Solving this, r Rydberg's constant, same cancels out each other. So we get 1 over lambda h alpha equals to 36, 9, 4 upon 1 over lambda h beta. It will be equals to 16, 4, 4, 16 minus 1. So solving this, we get 1 over lambda h alpha is equals to 5 over 36 divided by 1 over lambda h beta equals to 3 over 16. Solving this, we get 1 over lambda h alpha over 1 over lambda h beta. It will be equals to 5 over 36 into 16 over 3. 2, 8, 2, 8, 2, 4, 2 4s are 8, 2 9s are 18. So we get 1 over lambda h alpha, lambda h beta. It will be equals to 20 over 27. So therefore lambda h alpha over lambda h beta is equals to 27 over 20. Now comparing it with the given value x over 20. X over 20. So the value of x is equals to 27. So the correct answer is 27. Okay. Now moving towards our next question, question number 58. This question says that two transparent media having refractive indices 1.0 and 1.5 are separated by spherical refracting surface. Okay, they are separated by spherical refracting surface of radius of curvature 30 centimeter. The center of curvature of surface is towards the denser medium at a point object is placed on the principal axis in rarer medium at a distance of 15 centimeter from the pole of the surface. So the distance of the image from the pole of the surface is, we have to find the distance of the image from the pole of the surface is. Okay. Now solving this question as, let us say, this is our curvature. Okay. Spherical refracting surface radius of curvature 30 centimeter. Okay. Suppose let us say its radius is 30 centimeter. An object is placed here and the distance of the object from the pole is 15. Okay, this is 15 and refractive index mu is equals to how much? 1.5. Two transparent medium having refractive index in this is 1.0 and 1.5. Okay, this is 1.0, this is 1.5. Okay, we have to find the distance of the image. This is object distance. We have to find the image distance V. So there is a very simple formula for this, that is N2 over V minus N1 over U equals to N2 minus N1 over R. Now we have to find this value of V. So we will solve like N2 1.5 over V minus N1 1 over U. Since the object is on the left hand side of this curvature, so we will take U as, using sign convention, negative. Whatever an object or image, when the object and image are on the left side, we take them as negative due to sign convention, and when they are on right hand side, we take as them positive due to sign convention. So since the object is on the left side, so we will take it as negative. So u is 15 centimeter, means minus 15 equals to n2 minus n1, 1.5 minus 1 over r. Radius of curvature 30 centimeter. It is on the right hand side, so we take it as positive, plus 30. Okay, got it? Now solving this, we get 1.5 over v equals to 1.5 minus 1, 0.5 over 30 minus 1 over 15. Got it? So we get 30, 0.5 minus 2. So 1.5 over v will be equals to minus of 1.5 over 30. So v will be equals to 1.5, 1.5 cancels out each other, minus 30. So since v is negative, so it will be, the image will formed on the left hand side, and since it is negative, so it is formed on the left hand side of the surface of the curvature. Got it? Now, moving towards our next question, question number 59. This question says that a guitar string of length 90 centimeter vibrates with a fundamental frequency of 120 hertz. Okay. The length of the string produces a fundamental frequency of 180 hertz will be. We have to find the fundamental frequency. So the formula for the fundamental frequency equals to V over 2 into L, length 1 over 2L, and V is what? Under root of T over mass per unit length, mu. Okay. Since T and mu will be constant, the fundamental frequency, it will be directly proportional to 1 over L. It means F into L will be constant. Okay, so we can apply F1 L1 equals to F2 L2. Okay, so when the length is 90 centimeter, the frequency is 120 hertz. Now it is asking that when the frequency is 180 hertz, what will be the length? So solving this, 120 into 90 equals to 180 into L2. So L2 will be equals to 120 into 90 over 180. 9 into 2, 260. So L2 will be equals to 60 centimeter. Okay, L2 will be equals to 60 centimeter. Now moving towards the next question, question number 60. It says that a body of mass 5 kg is moving with a momentum of 10 kg meter per second. Let us say there is one body, it is mass is 5 kg and it is moving with a momentum p equals to 10 kg meter per second. Now a force of 2 Newton acts on the body in the direction of its motion for 5 seconds. Means suppose the body is moving in this direction, we have applied a force in this direction only, and the force is of 2 Newton and it is acting for the time of 5 seconds. We have to find the increase in the kinetic energy of the body. Okay, this question is from the chapter kinematics. Okay, so it says that, let us say, using the equations for the law of motion, the impulse is equals to change in the momentum. Change in momentum. So impulse equals to force into, for the time, how much is time it is acting. So force into time equals to change in momentum, delta P. Force is 2 Newton and it is acting for the time 5 seconds. It will be change in momentum, final momentum minus initial momentum. So 10 equals to final momentum. Initial momentum is what? 10 kg meter per second. 10. The final momentum is 20. Okay. Now it is asking for the increase in the kinetic energy. Since kinetic energy is equals to P square by 2m. So increase in kinetic energy means delta kinetic energy. It will be equals to final minus initial. Okay. So final kinetic energy will be equals to Pf square by 2m. Initial kinetic energy will be Pi square by 2m. So it will be equals to 1 by 2m Pf square minus Pi square. Okay, so Pf square is how much? 1 by 2m. Pf square 20 square minus 10 square. So it will be equals to 1 over 2m. 400 minus 100. Solving this, we get 2 into mass. Mass is how much? 5 kg. So 5 into 300. 300 divided by 10. So the change in the kinetic energy, delta K will be equals to 30 joule. Okay, so the correct answer is 30 joule.